The Airbus A320, one of the most popular passenger jets in the sky. Every day around the world, thousands of passengers board this plane. When they do, they walk through what would seem to be an obvious weak spot in the fuselage, the door. Any hole in the fuselage is a potential danger. So engineers designed passenger doors that can't be opened in flight.
It is virtually impossible. I don't use that word very easily, but it is impossible for a passenger to open a plug-type door in flight.
Passenger doors are plug-type doors. They're built to be slightly larger than their frames. When a plane takes off and pressurizes, the atmosphere inside the aircraft seals the door shut.
That door probably has 10,000 or more pounds of pressure holding it firmly in place in that door frame, and you have to pull it out of that door frame to get it open.
But not all doors on an airplane are built the same. Even designs that seem flawless on paper can rip apart in the real world. February the 24th, 1989, Honolulu Airport. United Airlines 811 is bound for Auckland, New Zealand. Expected flying time, 9.5 hours. There are 355 people on board, plus a full load of cargo. The doors close on time, and the plane leaves the gate just after 1:30 in the morning.
Tell them we can handle 33 if it's available.
Okay.
We did notice that there were thunderstorms 100 miles south, right on course, which was rather unusual for that time of night, so I left the seatbelt sign on.
Captain Cronin's decision to keep that sign on will save lives. As the 747 climbs past 7,000 meters, passengers sitting just above and behind the cargo door begin to hear a strange noise.
Kind of a grinding noise.
I heard like a thud.
The hell?
In the next nanosecond, it was pure, unadulterated pandemonium.
The next thing I knew, I found myself on the stairwell, hanging onto the rungs, and I immediately knew it was an explosive decompression.
Everything on the airplane that wasn't fastened down, tied down, or secured became airborne. The noise was incredible.
The 747's cargo door had torn off, ripping away a section of the fuselage. The pressurized oxygen in the cabin shot out with explosive force.
And as I looked up, that was the first time I saw this tremendous hole on the side of the aircraft that was just a void, and seats were missing, and I immediately knew that we had lost passengers.
Everything in front of us was gone. Where we were sitting, we were about 6 inches from the hole, so there was nothing in front of us or to the side of us. The whole side of the plane was gone. Actually, our feet were dangling on the hole, and I first thought we weren't going to make it. You know, I just didn't think there was any hope.
The situation is desperate, but by itself, an explosive decompression won't bring a plane down.
In 811, there's a hole as big as Tulsa in the side of this thing. I mean, it's an aerodynamic disruption of massive proportions, but if it was designed the way we had designed things a long time ago, it would have unzipped.
After the door came off, eventually a row of rivets held, keeping the plane from pulling itself apart. But the gaping hole is putting massive stress on the aircraft. The flight crew needs to descend as fast as possible.
Left, right, valves on.
Start dumping the fuel.
I am dumping.
Struggling to fly their badly damaged jet, the crew turned back to Honolulu Airport.
And all of a sudden, we were slowing down, and I said, oh my God, we've landed, we're on ground.
Probably the best landing I've ever made. When we finally stopped on the runway, we deployed all 10 chutes, and the flight attendants evacuated all the passengers.
Thanks to the experienced flight crew, United Airlines 811 landed with everyone on board alive. But 9 passengers were missing, sucked out of the plane when the fuselage tore open, taking with it 5 rows of seats. One of those passengers was a New Zealander on his way home, Lee Campbell.
We got a phone call from Chicago, and they just said that they regret to inform us that our son was missing, presumed dead.
In the wake of their son's tragic death, Kevin and Susan Campbell embark on an international mission to discover exactly why the door had come off the plane.
Lee can't have died for nothing. You know, you've got to find out why he died, and you've just got to make sure that it never happens again.
2 months after the accident, the National Transportation Safety Board holds preliminary hearings. During a break, the Campbells take matters into their own hands. They remove several boxes full of files.
So we quickly realised we'd got a really good set of papers with a lot of things that hadn't been released to the public. We were able to really start our investigation in earnest at that stage.
The unpublished documents reveal a disturbing catalogue of problems with the 747's forward cargo door, going right back to its original design. Passenger doors are plug doors, but most cargo doors on jets open outward. This increases the space for luggage and other cargo. As the plane gains altitude, the pressure inside the jet presses outwards against the door. To prevent the door from opening, Boeing had installed what it believed was a foolproof locking system.
What they do is they build in multiple redundancies to make sure the door is properly latched and does not open. And you build it in to a point of that it's extremely improbable that the door would ever open.
The Campbells' research uncovers 2 major flaws with the 747 cargo doors. The first involved the locking system. To lock the cargo doors, electric motors turn C-shaped latches around pins in the doorframe. A handle then moves arms or locking sectors over the top of the C latches to prevent them from reopening. But on Flight 811, the supposedly foolproof system had failed. Kevin Campbell built a model of the 747 cargo door latch. It showed the first deadly flaw in the locking system. Aluminium locking sectors could not hold the C-latch in place if the latches started to open on their own.
With the aluminium locking sectors, if the C-locks tried to backwind, open electrically, it would just push the locking sector out of the way. It just simply wasn't up to the job that it was designed for.
But what would cause the C-lock to backwind? The Campbells didn't have the answer, but they knew they were onto something. During their research, they learned that 2 years before Flight 811, a Pan Am 747 out of Heathrow had pressurization problems as it climbed to cruising altitude. The pilot was forced to turn back.
When they got back to Heathrow, they found that the door was hanging open 1.5 inches at the bottom, and all of the locks were open. When it got to the maintenance base, they found that all of the locking sectors were either bent or broken.
The passengers on this flight were lucky. They had survived the faulty locking system. But why had the C-latches turned and bent the locking sectors? As the Campbells continue to search, a Pan Am report surfaces that lays out a critical issue with the cargo door's electrical system. When the cargo door's outer handle is placed in the closed position, a master lock switch should disconnect the power supply. This would stop the C-latches from turning. But something was wrong with the switch.
There was power to the door locks with the
outer handle closed, and the lock started to move, and it started to force the locking sectors out of the way.
The faulty power switch and weak locking sectors were no match for the pressurized oxygen inside the plane. After years of being pushed by the Campbells, the NTSB produces a report that agrees.
There was an inadvertent failure of either the switch or the wiring that caused an uncommanded opening of the door.
It's nice that other people know that you're right and had been all along, and the support that they had given you was, was vindicated.
I couldn't have lived with myself if we had done no investigating ourselves. It was just something we both felt we needed to do. We didn't even discuss it. We just knew that's what we would do.
After United Flight 811, the locking system on the Boeing 747 cargo doors was changed. Inspections were increased. Another potential cause of explosive decompression had been found and eliminated.
That is an amazing accolade to what we've learned, not just Boeing, but what we've learned about maintenance, about structures, maintaining them, and inspecting them.
Since the first jet engines pushed planes higher in the sky, the aviation industry has struggled to harness and contain the deadly power of pressurized oxygen. They know all too well that a single flaw can lead to a terrifying decompression. But more than 15 years after United 811, another deadly lesson is learned.
Helios 522, do you read? Over?
It's August the 14th, 2005. For almost an hour, Helios Flight 522 has been circling the skies over Athens.
Helios 522, over.
Its flight crew has stopped communicating with air traffic control. Fearing a terrorist attack, the Greek Air Force scrambles 2 fighter jets to circle the mystery aircraft.
One of them was actually in a shooting position behind the 737. The other one was nearby the cockpit, and he was trying to communicate visually with the person in the cockpit.
The fighter pilots can't see any damage to the jet. No holes in the fuselage.
There is no structural failure. There is no fire. There is no problem, obvious problem, from the external view with the plane.
Someone in the cockpit waves at the fighter pilot. But all too soon, the jet loses altitude and falls towards the ground. All 121 people on board are killed. It's the worst air crash in the history of Greece. Within minutes, investigators are on the scene.
So we climbed over the hill, and there we were, facing this situation, which was beyond any description. I saw a great area in front of me, which was burning. It was black. Burning, people spread, pieces of the airplane.
The autopsies add more mystery to the case. Everyone on board the Helios flight was alive up to the moment of the crash.
They did not die from inhaling a toxic substance in the airplane or from an explosion. These people died on impact.
But if the passengers were alive until impact, why didn't the fighter pilot see more activity on the plane? Akrivos Tsolakis is the lead investigator. He begins to dig through maintenance records. He learns that on the day of the crash, the rear door had been inspected for leaks. Before it took off on its last flight, the Helios jet arrived in Cyprus with a problem. During the trip, the cabin crew had heard loud banging and saw ice on a rear service door. To make sure there's nothing wrong with the seal on the door, the engineer runs a pressurization test. He's looking for a leak.
So explain again how you tested the pressure.
I went into the cockpit,
I turned the pressurization switch to manual. Switching digital pressure control unit from auto to manual.
The jet's engines are turned off, so the engineer uses the plane's auxiliary power unit to force air into the cabin.
It's like looking for a leak in a tire. In this case, what you're having to do is pressurize the aircraft, use a barometer essentially to monitor the pressure inside, and look for leaks that way.
A normally well-maintained jetliner of any age is simply not going to be completely airtight. You're going to have leaks. As a matter of fact, as pilots, we know that certain airplanes are going to leak more than others, and you've really got to crank the pressurization up.
After completing the pressurization test, the ground engineer reports that the jet is in good working order. But the digital pressure control is left in the manual position.
They were supposed to return the selector to the auto position.
If the flight crew fails to see that the switch is on manual, their plane won't properly pressurize. The oxygen available inside the plane will be just as thin as the outside atmosphere. The passengers will be directly exposed to a deadly environment in which they cannot survive. August the 14th, 2005. The worst airline disaster in Greek history has stunned the nation. Investigators are sifting through the gruesome wreckage. A few minutes after 9 in the morning, Helios Flight 522 left from Cyprus bound for Athens. The crew has no idea that hours before takeoff during a maintenance test, a flight engineer has left a pressurization switch set to manual. Both the captain and co-pilot miss the fact that the plane is not set to pressurize automatically. As Helios 522 climbs, an alarm blares in the cockpit.
What is it? The takeoff config warning?
It's a non-pressurization warning, but it sounds identical to another alarm. The pilots confuse the two. It's a critical mistake.
The alarm sounded, and that alarm was misinterpreted. Most of flight crew, they will never face an alarm with no pressurization in all their flight career because it's a rare event.
Operations, this is Flight 522, over.
Flight 522, what can I do for you?
We have a takeoff config warning on.
Sorry, can you repeat?
As the pilots troubleshoot with ground engineers, life-sustaining oxygen is slowly seeping out of the plane. Eventually, oxygen masks drop in the cabin. They do not fall in the cockpit.
The reason that we don't have automatically deploying oxygen masks in a cockpit is simply too much up there, and if you had things popping out, they're going to hit switches that they shouldn't hit.
The crew don't realize they have a pressurization problem. Eventually, both the captain and the co-pilot collapse unconscious. The oxygen is too thin to breathe.
We're the ones that should be trained consistently to understand that ears popping, anything that indicates pressurization, you don't even talk to each other before you grab that mask and put it on.
The passengers are unaware that the plane is now flying itself. In emergency situations, chemical generators above the seats pump out oxygen. But there's a catch. These generators only produce enough oxygen for about 12 minutes.
Well, the problem with the passenger masks is, for one thing, they're not designed to keep you oxygenated at a high altitude. What they're designed to do is give you enough oxygen so that you can survive until the pilots get the airplane down to a low altitude.
But with both pilots already unconscious, the Helios jet did not descend so passengers could breathe without assistance. Instead, the plane flew on autopilot to Athens. When the oxygen supply stopped, the passengers passed out. By the time the Greek Air Force intercepted the Helios jet, only one person was still moving. Likely surviving with bottled oxygen, flight attendant Andreas Prodromou was still conscious when the fighters approached. He made it to the cockpit, but he couldn't save the plane.
Adonai Control, there is one person moving in the cockpit of Helios 522.
Eventually, when its fuel ran out, Helios 522 crashed. Investigators eventually find the panel with the pressurization switch.
Are you sure this is the way it was found? It hasn't been moved at all.
All 121 people on the Helios flight died because their plane didn't carry enough life-sustaining oxygen as it climbed into the sky. It's been more than 50 years since the beginning of the passenger jet era. 50 years in which the industry has learned, sometimes painfully, how to safely fly more than 10 kilometers in the sky.
When you look back at all the other accidents over the last 20 years, in most cases, we were pushing the frontier of knowledge.
Unfortunately, when you're pushing the envelope, you're pushing the boundaries of design, you can encounter problems that you hadn't anticipated.
In search of the safest plane imaginable, the history of aviation traces a flight path through tragic accidents to technological breakthroughs. Many of these accidents display the incredible power of explosive decompression. The Airbus A320 and every other passenger plane built today is infinitely safer than the first jets that flew in the 1950s. They have to remain safe and get even safer because we rely so heavily on this incredible mode of transportation that takes us somewhere we were never meant to be.